All right. Well, hello and happy Friday. All right. Let me get your attention, and we'll begin. Okay. So I just pushed these files to GitHub, so you should be able to git pull upstream main and get them. And today we'll look at working with files. So a lot of times we need to be able to interact with files and whatnot, and so we will do that. Okay. First we have this concept of persistence in that so far the code that we've been writing and running, they've been transient in that you open your Jupyter notebook, you run them, and they kind of they produce some output in your notebook, and you see it, and then it's done. Okay, and you save it in the notebook, and you can kind of open and read the output later, but those things do not exist in memory. Like the next time you open a new session, you don't pick up where you left off. If you run a line of code again or something, it's not going to remember those values. But anyway, so if you want to, kind of save your results for later and be able to kind of open and interact with it or whatever, you can kind of save an output to a file. All right. So the most basic command is going to be open. And so we can write to a file using the function open. We specify a file name, and then you can do W as an option, and this will open up basically a connection to the file that will allow you to write to it. And if this file does not exist, it will be created. Okay, so here we're going to call fout, and we're going to open the text. And what I'm going to do is I'm going to start writing to this file. So I'm going to just create this string that says this is the first line of text. I'm going to put in a new line character, a \n, and then I'm going to do fout.write line 1. Okay, so fout is basically the connection to this output file, right? So when I created open, this returns a connection to a file. Okay, and with this connection, I can now do .write, and this will, when I do this, that will update kind of output.text. And so here I'm going to kind of just open up my the file here from within kind of like my my Finder, and right now this doesn't have anything. Okay, so right now output is kind of it's blank. Okay, but I'm going to write this is the first line of text, and then I write line 2. This will be the second line of text. Okay, and I'm going to go ahead and write that line to the file, and then we close the file. Okay, and so this is kind of putting all of this output. This will be the first line, this is the second line. That's going into kind of Python's memory, into this connection, and then when you close it, it's going to kind of write and save it. So when I close it, it should, now that I have output open, and now when I open this file in from kind of my folder, it will now contain the lines of text. Right. So when I first opened it, and I'm kind of like writing these things to it, and if you try to look at what's inside the file, this output.txt file, you don't quite see it until you close that connection, and then that will kind of write everything to the file and save it. Okay, there is you can use this operator called with. Okay, and with the keyword you can have operations run with a particular file, and when these operations finish, Python automatically closes the file. So maybe I'm just going to add another one. Okay, and then so I'm going to do with open txt write as file. This is going to go ahead and again open up a file, and in write mode, we're just going to be writing things to it. So I do this, it opens and it closes the connection because I've used with, and if I were to open this, this has the 3 lines of text that I've added here. All right. In this case, I can do with open, and I can do read mode. And in read mode, it can read the file. And basically, when you do something like for I in file, it'll treat the file as an iterable, where each line is the entry that it can iterate through. So we're going to say for I in the file, and we're just going to print each line, and so it will print basically the 3 lines that are written in the file. Okay, we've seen the format operator, but here we have we can do a few things with it. Okay, so when using write, the argument that you're going to put into write, it has to be a string. And if you want to write, say, numbers or something like that, you've got to convert them to a string. And the easiest way to do that is using the this string function, right? And if you don't do it, you can run into problems. So here I've got the float. X is 42.3. Y is going to be, I'm going to do float plus is my favorite number. This is going to result in an error. Okay, so I try to run it, and it says unsupported operand for plus, float, and string. It says I don't know how to add floats and strings together. Okay, but what I can do is I can say take 42.3, put that inside string, and that will convert 42.3 into a string. And then I can use the plus operator, and that just joins them together into a longer string, right? And so that's no problem. I can print that output. All right, another thing that we can do is we can use the dot format operator, okay? And with the dot format operator, this is a string method. So basically any string that you have, you can write the string, and then you can do dot format, all right? And that will basically allow you to format the thing. And string, the dot format looks for curly braces and uses those as replacement fields, okay? Meaning that later on you can kind of replace the curly brace with some kind of variable. So here I'm going to say X is 12.34. So X is a floating point number, and then I got curly brace is my favorite number, right? So this is a string. And I can do, string.format X. And what this will do is it will replace the curly brace with the contents of X. Okay. There is, kind of this little language. They call it the format specification mini language, which tells you how do you format the text the way you want to do it. So I know in this past homework there's kind of some questions on how do I get all of these zeros and stuff, or to everything in that table to align. And the format mini language could be something that could be helpful in something like that. Okay, so I've got now I have 2 numbers, 12.34, 37.8, and here we can use we can have multiple curly braces, multiple kind of replacement fields. And in the dot format, you provide multiple arguments, and it will replace them positionally, right? So I can do blank is my favorite number, and blank is my second favorite number, and it's going to put 12.34 in the first position, and then x2 into the second position there. You can also kind of you can put an index in these things, and it will it will put things in the order that you specify. So in this case, I'm going to do index 1, which is our second position, and then index 0 is going to do this. So now we'll say 37.8 is my favorite number, 12.34 index position 0 as far as what I've provided inside the format operator. Okay, and then if you do it like this, you can then refer back to the same value multiple times. So I can say, again, my favorite number is, whatever's in index position 1. There are, if you want to specify your number appear a certain way with a certain number of decimal places or something like that, you can use kind of these colon operators within the replacement field. Okay, so the value before the colon will be the index 0, index 1, so on and so forth, or maybe like you can do a variable name. Okay, and then the colon after the colon will be basically how you want the text formatted. So here I've got x is 0.000 1 2 3 4 5 6 7 8 9, and then x2 is 0.0000 1 2 3 4 5 6 7 8 9. All right. The default, I believe, is it rounds to 6 significant figures. So it's going to keep the zeros and it will go up to 6. And if you want, you can say, like, I want to keep, say, 8 significant figures, and it will do, rounding, .8g. We'll keep 8 places. So keeping 6 significant figures, 1, 2, 3, 4, 5, and then it rounds the 6 to a 7. And then over here, we get 1, 2, 3, 4, 5, 6, 7, 8 values, and again that 8 gets rounded to a 9 here, and then it turns it into kind of scientific notation. Now, if you don't like scientific notation, you can use fixed point format, okay, which will be :F, all right, and again, if you don't specify a number, it will round off to 6. It will do 6 places. Okay, so not 6 significant figures, but 6 places after the decimal. So 0.000123, and then you can do something like .8f, and that will do 8 places after the decimal, and it will round anything after that. So I have 0.0000123. The 4 gets rounded up to a 5. If you don't want to use placeholders, you can kind of paste a whole bunch of stuff. So here we got my age is, and then you just take age, put it into a string, comma, and string x is my favorite number, and you could do it like that. That's one way to do it. As far as placeholder indices and putting the values in there, you don't have to actually specify them, and it will just do them positionally. So, you can do this. And so here, if you want to kind of replace it with a string, you can do, :s, and it will put it into a string, 100 years old, G83 is my favorite number or something. Okay. Just a couple more examples. So I have 012, 0 comma space, curly brace 1 comma space, curly brace 2, and we want to replace this with ABC. So that comes out ABC. Same thing, without any kind of positional indices, I get ABC. 210 will be what? CBA. Okay. Remember the arguments in here. We can do tuple unpacking, right? So here I have a string ABC, and then I can put a star in there, and it's going to treat the string ABC as basically an iterable with 3 characters in it, and it can unpack it. So you can do this as well, right? You can, here I have no spaces in between the curly braces, so our final thing will have no spaces in between these things. And then again, indices can be repeated, so I can do 0, 1, 0, And if you do that, with abra and cad, you get abracadabra, okay? You can also, so we've been using kind of just index position 0, 1, 2, but you can also provide names. So here I can say, hey, we want the coordinates to be latitude, comma, longitude. And then in the format, you can provide basically names for each of these values. So latitude being this and longitude being that. And there you go, right? You can also create a dictionary. So for the format operator, you can take a dictionary and you can unpack it as well. So here I've got a dictionary, which we can kind of see here. And then I can do coordinates, okay, and then dot format. And then here, because I have keywords and values, I'm going to do a keyword argument unpacking, which is 2 stars. So it works very similar to tuple unpacking, where it kind of treats everything in that tuple as individual elements. But in our case, we have a pairing. We have not just values, but we have keys and values. So this is keyword argument unpacking, and you do star star, and it will unpack the dictionary, and it will look for the keyword latitude, which it finds the key latitude associated with the value 37.24 n. Same thing with longitude. You can also left align or right align your text using the what looks like the less than, right, greater than, and the caret operator, but these are alignment operators as far as trying to format text. So here, less than 30 means the output needs to be 30 characters long, but we want the text inside format to be left aligned. So here, I don't know if you can see this, but it's left aligned on the left-hand side, and then it fills in, it pads it with spaces, and so that the entire length of the output is 30 characters long. Okay. Similarly, if I do greater than right, the text will be right aligned, and then if you do centered, it will do its best to center it. Now, depending on the what you specify, it might be off by 1 character. Like this side, I think might be 1 character longer than this side. I'm not 100% sure, but or maybe it works out fine. Maybe it is perfectly centered. Okay, but that's what we have there. All right, let me go ahead and give you your first view quiz answer. Question 1 is, let's see. All right, sometimes you want to interact with files on your computer, and you want to kind of like be able to look at things. So if you want to do that, you can use the OS module, all right? And that allows you to work with your computer's file system, import OS. You got to be careful. You have to be careful with import OS, because you can actually like start modifying the contents of files on your computer, right? So if you like within Python, you can tell you can write instructions to like delete files on your computer, and that could cause havoc. And so this is also an important thing. Whenever you download code off the internet, or just even copy and paste code off the internet, there could be like malicious instructions in there, right? So anytime you see like an import OS in there, just be careful. That means you're going to start modifying things on your actual computer, not just within Python. Okay. All right, so we're going to call os.getCWD. This will get your current working directory. So for me, I'm in, I have the folder 2023-fall stats21, and the way it's organized on my computer, I have users, my name, OneDrive, teaching 21, so on and so forth. Okay. you can do you can get relative paths and absolute paths. So a relative path says, here's my working directory, and then if you just do something like output.txt, the relative path just says, hey, looking at your current working directory, go to look for the file output.txt within that working directory. And if you want to say climb up the kind of the tree, the directory tree, you can do dot dot climbs up a level in the tree, or you can climb down into the tree by specifying a directory name. So here, output.txt is the relative path, and we could say, hey, what is the absolute path? Absolute path always kind of starts in the root directory. So on PCs, that would be C, and then on like a Unix system, it would just kind of be that first / okay, or that first backslash there. Okay, so here the absolute path of output.txt is, basically the absolute path of my current working directory with output.txt tacked onto it. Obviously, on your computers, when you call, get current working directory and output path, it should be whatever's relevant on your machine and not mine, right? Probably have your username. Maybe it's on your desktop. Maybe it's somewhere else. Okay. I think a lot of you just kind of created it in your home directory, so it might just be like tilde, your home directory there. Okay, there's a few things you can ask. Does a file exist? Okay, so you can do os.path exists, and we can see does memo.txt exist, and that returns false. Basically, this file does not exist. What about output.txt? We created that earlier, and that exists. We can ask, is something a directory? Output.txt is a text file. It's not a directory, so that's false. In my working directory, I have a directory called .git, which is where all of the kind of Git information is stored. And so we can say, is that a directory that exists? And I get it true. I can also list the contents of my directory using list the directory folder, cwd, and it kind of lists off all of the stuff that I currently have in my directory. There's a lot more stuff as far as Python OS functions go, right? I've kind of shown you some basic things, but you can certainly read more on here about, get your current working directory, and I don't know, there's all kinds of stuff here. And it will tell you, this thing is available on Unix. Some of these things don't exist on Windows, and whatever file object creation, things like that. Okay, so whenever you work with directories or work with files, I would say it's important to be able to catch errors and catch exceptions, just because a lot of times when you're trying to do something, things can go wrong, and Python will throw an exception. So when you try to open up a file or write to a file, you've probably encountered this where you have the same file open in two programs, and then you try to save it on one thing, and then it says you can't do it because it's open somewhere else or something like that. Stuff like that happens, right? So your operating system kind of is the commander of everything, and so it will allow you to kind of like open a file in multiple places. But when you first open a file, it kind of puts these generally some protections on it so that other files can't change it while it's currently open. Usually, I don't know, I think probably the latest version of Office has gotten smart about it and allows for things to kind of change and update and synchronize and things like that. But in general, if, this is probably like a common thing, if you're like working in RStudio and you knit a file into a PDF, and then you open that PDF, and then you try to knit it again, it probably errors out and says, it can't write. It can't write to that file because it's already open. So that's like kind of a common thing. And so those kinds of stuff happens, in Python. So anyway, just as a very basic example, here you can try to tell Python to open a file that doesn't exist. So I just created something and I said, I called the operator open bad file, and bad file is something that doesn't exist. And so when I try to do this, I get an error, okay? And the error says no such file or directory, bad file, okay? And so again, as you read, as you try to read the errors, we get something that this says, okay, this didn't work. So so there is kind of a pair of commands called try and except. It's kind of like an if-else. It's like an if-else. It's just rather than the if is kind of like if this is successful, don't do anything. But if it's not successful, do the except. So try this, and so first run this line of code, and if it works, just keep going. So if you do try open bad file and it actually opens, then the code just keeps going. But if this encounters an error, it's going to run the exception code. Okay, so it will do. So in this case, when we try to do open bad file, it's going to print something went wrong. Okay. Whereas over here, I could say open output.txt, and in that case, nothing went wrong, so it just keeps going. Yes, question?
Is it the same as the data cap, where it said like try and catch?
Yeah, it's much like try and catch, and actually, let me think. What's the difference between try and catch and try and accept? Try catch versus try accept. Try, accept, finally. Okay, well, all right, I don't know the answer. But yeah, the try, accept is kind of like, it's very similar to that, yeah. Okay, there is, oh, here, let me give you your second answer. What is it? B. Okay, we have, there is another data structure called the DBM, okay? This is, I guess, Python's little internal database thing, all right? This is, when a lot of times when we think database, we think like SQL, SQL, or something like that. This is a much more rudimentary version. It's not a relational database. It's basically a dictionary. You have keywords, you have values, and but the thing about the DBM is that it's going to store it on your kind of hard drive into a file here. Okay, so in order to do this, we import the DBM library. Okay, and then we'll do dbm.open. Okay, dbm.open will open the database connection. Unlike file.openWrite, it doesn't just wipe out the contents of the file. So here we can do dbm.open, and we're gonna open a directory called captions. And so, if you did a thing, there's a data file called captions.dat. This will be our captions directory. This is, if you tried to open it, it's like there's all kinds of stuff that's very difficult to read. Okay, there's like plain text, photo of John Cleese, photo of Terry Jones. Okay, actors from Monty Python is what these things are. But you know, it's stored in there. But there's also a bunch of like extra characters. There's Python kind of creates a this dot back. I don't 100% know what this means, but basically, you know, the information gets created when you do these things, and you can kind of see what these things look like. I think this is the same thing. .dir. So anyway, these three files get created: captions.back, captions.dat, captions.dir. I think the two main files are this, and I think this is a backup file, but I don't 100% know. So anyway, we're going to just do captions, C, and this is going to create a connection to the database. All right. So we do dbm.open. We're going to store the whatever dbm.open returns as db, and so now I can do db dot, or I can reference this database, and it will be kind of the connection to this thing. And so we can add values to the database, much like we add or update values into a dictionary. So I do db cleese.png. So the idea here is we wanted to store captions for files. So you can imagine somewhere on your computer you have a picture, okay, picture files, and you wanted to add captions to these picture files. And so I don't have cleese.png on my computer, and it doesn't really matter. That's beside the point. We just want to create a little entry into our database where the keyword or the key is cleese.png, like a dictionary, and then the data is this string. So, you know, it could be something much longer, but here we just have photo of John Cleese, okay? And I'm just copying the examples from the Think Python textbook, where the author is a fan of Monty Python, and I guess kind of with the theme of Python. Yeah, question?
If you don't have the photo file saved, does it just save to the database?
So this is just an arbitrary string set of characters. It's just an arbitrary string. So it doesn't actually matter if there is actual a cleese.png file or not. This is just saving. We are just creating a key. The key happens to be this character string, cleese.png. It doesn't actually matter. I could change it to whatever else. And it's just going to save it into this captions database file that here I'm just opening a connection that I can create or modify. Okay, and then and so if we have that, we can retrieve values, much like we retrieve values from a dictionary. And here it says here's the text there. I think the B is binary or something. Okay, here we're going to add another thing, and we'll do jones.png is photo of Terry Jones. And if you want to delete entries, much like deleting an entry in a dictionary, you can call delete, del, and whatever it is that you want to do. All right, and so what we can do is we can take our go through the entries in our database, and we can just kind of say like, hey, what's in there? And so we can say for each key in the database, print out the key, print out whatever value is associated with the key. Oh, and I forgot. Okay, so later on, I created a list. So this thing is in there from an earlier. I guess I ran all of the code. So later on, we will add the list to the database. Okay, but yeah, we could change any of these things and add or delete keys. Okay, as always, whenever you work with a file, you should close the connection to the file when you are done. So we're going to just do db.close. When you create this captions DBM, it's going to add files to your working directory, and so we can kind of ask go through. So remember, os.listDirectory.cwd produces basically the list of all of the files in our directory. And then we can say if it's a file and that file name contains captions, then print that out. And so we could see what files have captions in it, and we get these 3 files. Whenever you create a DBM, these are what we have. Okay, now one major limitation of a DBM file is that the DBM is only able to store strings or byte objects. And if you want to store other objects that you create in Python, you have to what we call pickle them, all right? And what this will do is it converts a Python object into a string that can be written to the DBM. So I guess it's kind of like, it's the idea of like if you want to store some food in your fridge long term or something like that, there's the pickling process. Did I just run out of power? I don't know. Okay, I don't know what just happened. I'm not anywhere close to running out of power, I don't think. I'll plug in just in case.